This time, we are tasked to determine the Laplace transform or to evaluate the Laplace transform of the function e to the power of t plus 7. Now, we do have a rule for the Laplace transform of e to the power of t, right? The rule for e to the power of t is equal to, you have here 1 over s minus 1. This is the rule for our e to the power of t. Now, we also have other version. If our exponent is actually equivalent to a certain alpha t, this is equivalent to 1 over s minus whatever your alpha is. But this time, since our exponent is a binomial expression, t plus 7, what do you think or is the result when we try to take out the Laplace transform of the given function? Now, some of you might think that since our alpha t there, or this would be our exponent, that would be our exponent here, so you're just going to get the numerical coefficient of t plus 7 to take it here. Now, it's not true all the time. Okay, what you need to do here is actually look into the given. Our e to the power of t plus 7 could actually be written in this manner. So you have here the Laplace transform of e to the power of t plus 7. This could be written as this, and it's actually easier than what it looks like. It's actually equivalent to e to the power of t times e to the power of 7. Okay? Because by multiplying same bases, e, you add exponents. So if your exponents is a sum, you can break it into two different exponentiations of the same base, and you have your exponents there. Now, I mentioned this is actually easier, but what you are seeing here is a little bit complicated. The reason for that is e to the power of 7 is actually a constant. According to the linearity property, you can simply take that out. Therefore, you have this form, e to the power of 7 times the Laplace transform of your e to the power of t. Because e to the power of 7 is a constant, it doesn't include any variable of t. So with this now, we know that this is equivalent to this form. So this is equivalent to e to the power of 7 times 1 over s minus 1. Okay? So basically the result here is just simply e to the power of 7 over s minus 1. This is the Laplace transform of our e to the power of t plus 7. As easy as this, we don't need to actually use this notation, but of course you can try this on your own. If you have the same result, integral from 0 to infinity of e to the power of negative st, you have your ft dt, where your ft is actually equivalent to your e to the power of t plus 7. Please try to do that on your own, and I think you will get the same result as this by applying already the rules that we have identified in the linearity property. Now, for some references, I would like to add something here. We actually have additional consideration here that s must be greater than 1. Okay, so that our denominator is greater than 0, so that our limit for this is actually converging to a certain value as t approaches to infinity. But not to be confused with that, let me remove this. So this is actually just the Laplace transform of our given function. Thank you very much for watching.